Right, so welcome to all. Our course is Mechanical Measurements and Metrology. So as per our agenda, today we are going to the strain measurements. Right, so the learning outcomes are the learners will be able to select suitable instruments for strain. Okay, so these are the content. So we have two content. One is strain gauge factor, another one is a mechanical strain gauge. Right, so before begin strain. So if our human body can work more than 8 hours, by 8 hours we can work. If the working hours is increased, if working hours increase, we will get some body illness. The reason is our body gets strained. Right, so our capability, if I do more than our capability, then I can get the stress. Due to the stress, the cause is strain. So stress causes is nothing but our strain. The same way, the material may get stressed. So one of the examples, for example, I have a material. That material maybe can withstand 10 kg of weight. Assume that material can withstand 10 kg of weight, but I am using that material to hold more than 10 kg. So what will happen? The properties or the materials it may get some strain. The reason is it is only capability is 10 kg, but I am loading more than 10 kg. So it will get the stress. So the stress causes the strain. Right. So strain is very important property to measure the object. For example, we have elastic limit. So every material has an elastic limit as well as plastic limit. So elastic limit means if you keep on increasing your stress, the strain will increase. Within the elastic limit means if you reduce your stress, then the strain also reduces. This is what up to elastic limit, right? So it's a Hooke's law. There's a different category, right? So if more than elastic limit, if it is in plastic state, if you keep on increasing your stress, the product gets strained. So if you reduce your stress, then it won't regain its original shape. Right. So if after elastic, for example, I have an elastic limit of plastic limit of 10, assume that unit is 10. So if more than plastic limit, the material will break. Right. So we need to maintain the strain up to control level, or we need to ensure whether we are giving enough strain. So based on our strain, we need to select our material. So material strain is a very important factor. Right. So the introduction, the definition of strain is nothing but it's a geometrical measures of deformation representing the relative displacement. Right. So it is a relative displacement. So for examples, you have an iron rod. Assume that you have an iron rod. You keep on increasing the temperatures. So the furnace was the temperature is from the iron rod. So if the temperature rises, then the material gets deforms, or the material get maybe elongation aglam, right? So it may be compressed aglam, whatever it may be. Depends on the material property, it may elongate. Generally, all the materials are elongated if you increase the temperature. So previously, the iron rod should be the 10 mm, assume that. So 10 inches. If I increase the heat, it may changes 12 or 11, or it may be 9.5 or 8. So definitely the length will changes, or the material gets, because the metal gets deformed. So the strain is nothing but the ratio of change in length by original length. So there is no unit because both are in meter. If you measure length in meter, then both are same unit, then there is no unit. Otherwise, if you measure the length in inches, the ratio, both the values are same unit, so you don't have unit. So unit is so strain is a geometrical measures of deformation representing the relative displacement, which means relative, which means relation to others. So relation is relation. Maybe for example, so my father son. So father and son relations, or son and father relations, our relation. So this is we need to compare. Comparisons are relative. So relative displacement means at beginning displacement, after force or after thermal stress, whatever it may be, applying the force or stress, what are the final? What is the final state? So the relation between initial and the final state is nothing but our strain. Right. Right. So why we need strain? So need of strain measurements. Main important is the problem of determining stress acting on your body has been an important and interesting aspects of materials engineering, right? So it's very important. Stress determination is very important for material science. So based on our material selection, for example, in our bike we have IC engine, so internal combustion engines. So engine parts are made by the composite material or some metal parts. We can't make IC engines in plastics. The reason is the temperature during during the working of IC engines, the temperature may increases. The material should withstand those temperatures. Otherwise, என்ன ஆகும் அப்படின்னா ஒரு மாதிரி மெட்டீரியல் வந்து வேஸ்ட் ஆகிடும். ஸோ அதனால தான் எங்கே டெம்பரேச்சர் ரைஸ் ஆகுதோ அங்கெல்லாம் பார்த்தீங்கன்னா we use some metal parts or some composite materials. So it is a very important in material engineering to determine the stresses. So when external forces act on your body, the body is in condition of stress and strain, right? So if any object, ஏதாவது ஒரு ஆப்ஜெக்ட் இருந்துச்சு அப்படின்னா கண்டிப்பாக அந்த ஆப்ஜெக்ட் மேலே if you apply any force or stress, ஃபோர்ஸ் பண்ணீங்க அப்படின்னா ஃபோர்ஸ் ஏதாவது கொடுத்தீங்க அப்படின்னா கண்டிப்பாக அது ஸ்ட்ரெஸ் ஆகிடும். ஸோ ஃபார் எக்ஸாம்பிள் ஐ ஹேவ் வாட்டர் பாட்டில் அப்படின்னா வாட்டர் பாட்டிலில் நீங்கள் ஒரு ஃபோர்ஸ் கொடுத்து ஒரு இடத்துல மூவ் பண்ணீங்க அப்படின்னா இட் வில் மூவ், பட் இட் வில் ஆல்சோ கெட்ஸ் ஸ்ட்ரெஸ் அண்ட் ஸ்ட்ரெயின். அந்த இஃப் ஸ்ட்ரெயின் ஸ்ட்ரெஸ் வந்து எலாஸ்டிக் லிமிட்டோட கீழே இருந்துச்சு அப்படின்னா ஸ்ட்ரெயின் திருப்பி ரீகெயின் ஆகிடும். அது சேஞ்ச் லென்த் திருப்பி அகைன் ஒரிஜினலுக்கு வந்துடும். இஃப் இட் இஸ் பிளாஸ்டிக் ஷேப்பில் இருந்துச்சு அப்படின்னா பெர்மனன்ட் ஷேப் சேஞ்ச் ஆக மாறிடும். If more than plastic shape, it will break. So since the direct measurement of stress is not possible, so stress is a very important factor, but we can't measure stress in direct way, but we can measure the causes of stresses. So causes அப்படின்றது என்ன ஸ்ட்ரெஸ் ஆனால் என்ன ஆகும் அப்படின்னா it may be the change in length, change in the dimensions. So its effects such as change of shape of the body or change in length are measurable, just providing a known relationship between stress. So if we measure the causes, then we can measure the stresses. So stress directly measure பண்ண முடியாது. So if we measure the causes of stress, then we can measure the stress. Causes வந்து stress measure பண்ணலாம். So this is what need of strain measurements. Okay, so the purpose of strain gauges. So strain gauges is one of the device which is used to measure the strain, right? So why we need strain gauges? The purpose of strain gauges means it mainly works. It has mainly two functions. So two different purposes. One is to determine the state of strain existing at a point on a loaded member for carrying out the strain analysis. Right. So ஒரு loaded memberல நான் ஒரு stress கொடுக்குறேன், ஒரு force கொடுக்குறேன் அப்படின்னா what kind of strain will occur? அதை identify பண்ணுறதுக்கு we need to use strain gauges. The second one, to act as a strain sensitive transducer element in the measurement of quantities such as force, pressure, displacement, and acceleration. Right. So first one, it is used to measure the strain. So determine the strain, first factor. The second function is it acts as a strain sensitive transducer element. Okay. So again, we know that if I measure the temperature, the instrument should sensitive to temperature alone, not other parameters. நான் டெம்பரேச்சர் மெஷர் பண்ணுறேன் அப்படின்னா அந்த இன்ஸ்ட்ருமெண்ட் வந்து டெம்பரேச்சர் மட்டும் தான் சென்சிட்டிவாக இருக்கணும். அதர் ஃபேக்டர்ஸ் சென்சிட்டிவாக இருந்துச்சு இல்லை அதர் ஃபேக்டர்ஸ்லாம் ரியாக்ட் ஆச்சு அப்படின்னா the values may be changes, so the errors will happen. So for example, if you are going to measure the force or pressure or the displacement or acceleration, whatever it may be, it must sensitive to those parameter only. So force measure பண்ணுறோம்னா ஃபோர்ஸ் மட்டும் தான் அங்கே வந்து சென்சிட்டிவாக இருக்கணும். Remaining factor வந்து insensitive இருக்கும், which means அது எந்த எஃபெக்ட்ஸ் இருக்கக்கூடாது. But we can't avoid other effects அவாய்ட் பண்ண முடியாது. ஸோ இப்போ ஸ்ட்ரெயின் இருக்கும். இப்போ நான் ஃபோர்ஸ் மெஷர் பண்ணுறேன், ஆனால் எனக்கு ஸ்ட்ரெயினோட வந்து எனக்கு இன்எஃபெக்டிவாக கொண்டு வரணும், இன்சென்சிட்டிவாக கொண்டு வரணும் அப்படின்னா ஐ கேன் யூஸ் ஸ்ட்ரெயின் காஜஸ். ஸோ ஸ்ட்ரெயின் காஜஸ் என்ன பண்ணும் அப்படின்னா இட் ஆக்ட் அஸ் அ ஸ்ட்ரெயின் சென்சிட்டிவ் டிரான்ஸ்யூசர் எலிமெண்ட். ஸோ அந்த ஸ்ட்ரெயின் வரதை இட் வில் அப்சர்வ், ரைட்? ஸோ டிரான்ஸ்யூசர் is nothing but it's a device which converts one form of energy into other form of energy. So if I measure the force, but the strain will act. The strains are absorbed with the help of strains and transducer, and it will indicate the signal. The strain வருது, values திருப்பி எடுங்க. So this is what strain causes. So strain causes mainly used for two purposes. One is it is used to determine the stresses or causes of stresses. So strain, determine the strain. The second one, it acts as a strain sensitive transition element in the measurements of quantities such as force, pressure, displacement and acceleration. Okay, the measurement of strain. So so assume that I have a cylindrical rod with the length of 10 meter, right? So assume that 10 meters. So 10 meters is a huge one, right? So I'm going to give the pressure at any one point, but I cannot measure the entire length. The reason is we can't measure entire length. We can't measure entire length measure பண்ண முடியாது because we don't have that kind of facility. அப்போ என்ன பண்ணுவோம் அப்படின்னா, if I have a 10 meter rod, I'm planning to measure the strain. I have a segregation. So for example, segregate பண்ணுவேன். 10 mm I have a 1 mm 10 parts split பண்ணுவேன். So 10 mm 1 mm split பண்ணிட்டேன் அப்படின்னா, if I have an instrument to measure 1 mm strain அப்படின்னா, I will measure the strain 1 mm. So for அந்த 10 mm நான் 10 times measure பண்ணுவேன். So measurements are made over the shortest gauge lengths. So அப்போ நான் entire distance measure பண்ண முடியாது, ஒரு shortest length மட்டும் தான் measure பண்ணுவேன். So அதுதான் ஒன்று. Normally measurements are made over the shortest gauge length. The change in length measured over a finite length does not give the value of strain at a fixed point, but rather gives the average strain over the entire length. So இந்த மாதிரி தான் measure பண்ண முடியும், but it won't give the exact value. It will give the average value. So we need a magnification system. Is essential because we are going to measure our object அதுக்கு strain measure பண்ணுறது entire object ஃபுல்லாக வச்சு measure பண்ண முடியாது. எந்த இடத்துல strain maximum வரும்னு எனக்கு தெரியுதோ அங்கே மட்டும்தான் I can place my strain gauges or other gauges. So I know this place has more strain. So அந்த இடத்துல I will store. So maximum எங்கே இருக்கும் அந்த strain measure பண்ணுறோம் அப்படின்னா we can measure remaining. So அதுக்கு மேலே வராது. So we need a magnification system. It's essential since the change in length is over a small gauge length. So we need to magnify. Again, the change in dimensions may be measured in some quantities like capacitance or inductor or resistance type. But human cannot read those electrical quantities. So we need some digital meter or other auxiliary device to convert reading as a compatible mode. So we need a good magnification system. It's essential. Okay, so the types of strain gauges. So we have two types of gauges. One is mechanical, another one is electrical. In mechanical, we have a extensometer. In electrical, it can have a two classification like unbonded and bonded. And bonded, we have a three more type: wire, foil, semiconductor. And semiconductor, we have a two more type: P-type and N-type. So this is the overall types of strain gauges. So strain gauges have a two classification based on the working principles. So if mechanical deformation, then we can say it's a mechanical. Electrical is nothing but electrical quantity. So mechanical, we will see only one example is extensometer. Electrical, we have a two more type: unbonded and bonded. Right, so and we have further classification: bonded. Right, the two types of strain gauges are employed. One is a mechanical, another one is electrical strain gauges. Electrical strain gauges can be two classification: unbonded and bonded. And bonded, we have a wire and a foil and a semiconductor. And semiconductor, we have a two more type: P-type and N-type. So we are going to see this all. Okay, the first one is mechanical strain gauges. Right, this is the Berry strain gauge extensometer. Why we say Berry means it is designed by Professor Herman C. Berry of University of Pennsylvania in 1910. Right, so it is designed by him. So we provided this name. Right, designed by Professor Herman C. Berry. So we give that name, Berry strain gauge extensometer. So it is employed for measuring a small deformation under linear strain conditions over gauge length up to 200 mm. So it is used to measure linear strain. So linear strain ஒரு ஆப்ஜெக்டை வந்து இப்படி டென்ஷன் கொடுக்குறோம் ஆர் கம்ப்ரெஷன் பண்ணலாம். ஸோ லீனியர் ஸ்ட்ரெயின். ஸோ tension or compression strain we can measure. It is employed for measuring small deformation and the linear strain. The length பார்த்தீங்க அப்படின்னா காஜ் லென்த் பார்த்தீங்க அப்படின்னா காஜ் லென்த் இஸ் நத்திங் பட் I said we can't measure entire length, so we can split as a gauge length, right? So for the previous example, I said 10 meter rod. I'm going to measure the strain, so I split 1 meter each, so 10 gauge lengths. So gauge length is 1 meter. So here gauge length up to 200 mm we can measure with the help of mechanical strain gauges. Okay, so how it works, right? So this is the very strain gauge extensometer. So we have two gauge points. One is a fixed point and another one is a magnifying lever. Right? So one is a fixed point, another one is a magnifying lever. So both the points are placed at the top of the specimen. So specimen is nothing but our workpiece, or where we are going to measure our strain. So எந்த ஆப்ஜெக்ட்ல நம்ம ஸ்ட்ரெயின் மெஷர் பண்ண போறோமோ அதுக்கு மேல we are going to place a point. One is a fixed point, another one is a gauge point. So the gauge point can be vary, but extensometer பொறுத்த வரைக்கும் we can measure up to 200 mm maximum. Right? So assume that this is our specimen. Right? We are going to measure the strain for this specimen. We place our vary strain gauge meter on top of the specimen. This extensometer have two fixed points, gauge points. One is a fixed point, another one is a gauge point. So the distance between fixed point and gauge point is nothing but our gauge length. And the extensometer has a pivot and lever. Right? So if this is the fixed point, right? So if the gauge point may deflect, may deform, or it may move up and down. So the gauge point it may move up and down. So for example, if the gauge point moves downward direction, then the lever also deform. Levers are connected with the gauge point. So in the gauge point, if it moves downward direction, then the lever also deform. The lever is connected with the dial gauges. So dial gauges is one of the instrument. It is look like our watch. So in watch we have a indicating hand. So no time irukum 1 to 12 varaikkum time irukum, and then we have a indicating hand irukum. So first, before applying force, I am fixing the fixed point as well as gauge point. That I fix panniten specimen mela fix pannittu I set the value as 0. Dial gauge irukku watch maar irukum. So on the indicator I 0 set panna. I have a adjustment screw irukum. The screw adjust panni initial position without applying any force I set the value as 0. If the next I am giving the force, so here I am giving the tension force, right? So here I am giving the tension force because both the forces are different direction. So here I am giving the tensile force, so the specimen gets tensile strain. So elongate ஆச்சு அப்படின்னா the cross section of specimen it may changes. So this cross section change ஆச்சு. So here tensile elongate ஆகுனா specimen diameter பார்த்தீங்க அப்படின்னா definitely it will reduce. So reduce ஆச்சு அப்படின்னா the gauge point will move downward. So gauge point will downward ஆகும். So it is connected with the lever. So leveரும் கீழே deflect ஆகும். It is connected to the dial indicator. Previously we set the value 0. Due to the strain, the lever gets deformed. So the values are changes. So lever deform ஆகிறப்ப the 0 portion will change ஆகும். That is nothing but the strain. Right? So the working principle is very simple. So we have two points, fixed point, gauge point. Both are placed on top of the workpiece or specimen. If first thing we set the value as 0, in dial indicator we set the value as 0. After that we are giving the force to the specimen, so the material gets deformed or the material gets deformed. It may be compressor, it may be tensile forces. So for here I am applying the tensile force, so the tensile strain will occur. So the change in cross section of the diameter of the specimen will reduce. So the gauge point will move downwards. So it will come to the lever. So lever also move downwards. So it will get deformed. The deformed and the dial indicator it shows some value. This is the working principle of mechanical strain gauges. So here we measure strain with the help of mechanical deformation. So ஒரு length ஒரு liver வந்து deform ஆகிறத வச்சு measure பண்ணுறோம். liver ஏன் deform ஆகுது அப்படின்னா specimen deform ஆகுது. right? So lever deform fixed point, Kaji point or variation, Kaji point deform move the specimen more. So we are going to measure the strain with the help of mechanical deformation. That's why this is comes with the mechanical strain causes. So both points are placed on the specimen. The displacement caused is magnified by the lever and is indicated in the dial indicator. So the displacement of the gauge point will transfer to the dial gauges. Strain is determined by the dividing the measurement displacement over the gauge length. So over gauge length the measurement we have some value. So if it is if you have a 10 gauge length, so you need to measure 10 times. So the average is considered the strain. Right, so this is a mechanical strain gauges. Okay, applications are it is used in civil engineering for structural applications. Right, so for structural application it will use. Advantages, it contains self-contained magnification system because we have a mechanical elements like lever, point, all those mechanical elements. So it is a self-contained magnification system. No need to use auxiliary equipment. Here magnification is converted via lever. So now electrical quantity convert I don't need a separate auxiliary equipment. So here no need to use auxiliary equipment. Best suited for conducting static tests. So static tests strain on the static portion we can use mechanical strain gauges. So we have some limitations also. One is the response is very slow due to high inertia and friction. Automatic recording of the reading is not possible, right? So it is very difficult to record. Automatic record mechanical extensometer manually you need to store. You need to check your dial gauge and you need to note it down the value. There is no automatic recording of the reading and cannot be used for dynamic strain measurements and it varying strains. So can dynamic measurements if the strains may be variation we cannot measure with the help of mechanical strain gauges. So thank you. So this class we learned what is meant by strain, what's the need for to measure strain, what type of strain measurements we have, what the instrument called the strain gauges used to measure the strain, types of strain gauges, electrical, mechanical, and we saw mechanical strain gauges or mechanical strain gauges. So thank you.